Hey everybody, in this quick recording, hopefully quick, I am just going to go through more or less kind of from the beginning with all of the trig identities that we've done this far that you should really have handy in your notebook. Better than that, handy in your memory, so that while we're doing these more advanced trig equations or trig identities or simplifying trig expressions, that you have this like arsenal of information just at your disposal and ready to go. So let's go ahead, write down a nice and organized table. So I'm going to start off with with my reciprocal identities. Reciprocal, reciprocal. Now I'm not going to write the word identities after each one. I think it goes without saying. So I'm going to jot them down. It is possible to just write down 3 reciprocal identities and imply the other 2, or I'm sorry, the other 3 out of those 3. I'll list them all for you so that you have it all kind of written down. Sine theta as a reciprocal identity is 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. Tan theta, and I always go in the same order with my trig functions, as you may have realized, is 1 over cotangent theta. I'm just gonna, my dog is trying to jump up on the window ledge. Come here. You wanna go up there or not? Here, chill there. Okay, bud? Sorry. Then we go to really these 3 denominators, okay? And we have cosecant theta equals 1 over sine theta, secant theta, 1 over cosine theta. Of course, he's coming down now. And cotangent theta is equal to 1 over tangent theta. So they are reciprocals of each other. What goes one way also goes the other. It doesn't matter what theta is. Theta could be 2 theta. Theta could be 3 alpha. Sine of 3 alpha is equal to 1 over cosecant of 3 alpha. Okay, they will match up. They could all be squared. Sine squared theta equals 1 over cosecant squared theta. All right, so as long as it's consistent and all matches, you are good to go. So that right there, those are our reciprocal identities. You need to know these by heart, okay? I don't silly arrow on. We don't need that right now. There we go. Okay. Next, the next set of identities we looked at were the quotient identities. Now, normally we kind of just look at sine over tangent equals this, cotangent equals that, but I had those 2 bonus ones for you. They all equal each other. Okay, it's like a triangle of things that they all equal, okay? So I'm going to write them a little bit differently than I wrote them before because I feel like people were not understanding entirely. But tan of theta, it can equal, typically, the first one we say is sine theta over cosine theta. Or we could also say that it equals my bonus one, this is special, secant theta. I know sine is on top and that you associate sine with cosecant, but please, sine on top is the same as cosecant on bottom. So, and then a cosine on bottom, right over here, see, is the same as secant on top, because that's over a 1, really, right? So the equivalent, cosine on bottom is secant on top, sine on top is cosecant on bottom. Or we could just remember it's S over C, and that they're all equal to each other, okay? So I kind of wrote it in a circle this time. And then I'm also going to do the same idea, but for cotangent, right? And cotangent is the reciprocal of tangent, so it's literally the flip of all of this stuff. So first I'm going to write cosine over sine. Down here I'm going to write cosecant over secant. Secant, cosine on top is the same as secant on bottom. Sine on bottom is the same as cosecant on top. And that really, other way to remember is that C will be on top and S on bottom. So C is on top for cotangent. S is on top for tangent. I know it's not the same letter, but they're neighbors in the alphabet, right? So help you remember your quotient identities over there. Okay, it's still true if it's 2 theta for everything. It's still true if it's alpha for everything. It's still true if they're all squared. All right, the same rule will apply. So that is the end of our quick little quotient identity review. All right, next ones that we'll have, and for more detail on these, you know, we have other videos, but the Pythagorean identities. Now these constantly are getting rearranged, rewritten, and looked at in different ways. So the different arrangements, you got to know those or how to do those. I'm just going to write 1, 2, 3. How they're related to each other, definitely in a previous video. We're trying to keep this brief, okay? What are the Pythagorean identities? They are sine squared theta plus cosine squared theta equals 1. Next up, if you divide everything by cosine squared theta, we'll get the new one. It is tan squared theta plus 1 equals secant squared theta. Go back to the original, divide everything by sine squared theta, and we get the third one, 1 plus cotangent squared theta equals cosecant squared theta. And that is the end of our quick recap of the 3 Pythagorean identities. All right, what else do we got? We did reciprocal, we did quotient, we did Pythagorean. Let's do the angle, sum, and difference identities. Now, I don't know if this was a mistake or not, but I consolidated 2 identities into one for you guys in the notes. And some people just don't get it. You don't understand that that is a twofer, you know, like you have 2 identities written in one. So guess what? I'm going to write them separately because people don't understand. So look at this. Angle, sum, and difference. Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta under sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. Maybe it'll finally click. I have no idea. But in the notes, I had written sine of alpha plus minus beta, mushy, consolidate, boom, equals sine alpha cosine beta plus minus, smushy, consolidate, cosine alpha sine beta, you know? But people aren't understanding that it's 2 identities. Stop writing both signs. Pick one, the one that you need. If you don't get it, they're here separately now. There you go. Next, cosine. It's a different rule for cosine, guys. Not the same rule as sine. That's why they're different. They're different. So don't just try to make it up, okay? Cosine alpha plus beta equals cosine alpha cosine beta minus, so then that's plus, this is minus. That's why when I consolidated, I had plus minus, and then I had minus plus. It's the opposite. Sine alpha, sine beta, and then, oh my gosh, I'm sorry if you hear my dog. Cosine alpha minus beta, lunchtime, so he knows he usually goes for like a good long walk at this time. Cosine alpha, cosine beta plus sine alpha sine beta. I'm going to squeeze 2 more down here for tangent. We're going to squeeze 2 more down here. And then up here, we're going to do our double angles. And that'll be enough for now, okay? So for tangent, we have tan alpha plus minus beta, or plus beta, sorry, just plus, equals, I'm going a little crooked. I should have written that lower because this is a fraction. Here's my fraction bar. Tan alpha plus tan beta over 1 minus tan alpha tan beta. Again, I also wrote this as 2 in 1, but now I'm writing them separately. And then the last one is tan of the difference, alpha minus beta equals, oh boy, tan alpha minus tan beta over 1 plus tan alpha tan beta, like that. All right, those are the sum and difference identities. So we had done these 3 sets, reciprocal, quotient, Pythagorean, back in like lesson 13-ish. And then we are doing sum and difference we did in 19. And then up here, lesson 20, we're double angle identities. I did say I wasn't going to write the word identities, but I did for that one. It's kind of going to bug me. I kind of want to white it out because it was implied. I know it doesn't matter. Forgive me for being a lunatic. Okay. Double angle, sine 2 theta. You don't need those parentheses around 2 theta. When I first did the notes on it, I wrote it with and without. But guys, the 2 and the square over here, these got to look different. If your handwriting is questionable, you know, you got to figure something out. Since I didn't use parentheses anywhere else, I'm actually going to not use them for the notes here. So sine of 2 theta, nice clear 2. That is 2 sine theta, cosine theta. That is an identity, a rule, a formula. All of these things are things you could swap one thing out for the other. They're equal. Next, cosine 2 theta. Cosine is special. We got 3 options for this guy over here. We could have either cosine squared theta minus sine squared theta, or we could have 2 cosine squared theta minus 1, or we could have 1 minus 2 sine squared theta. You have 3 options. All of them have minus in the middle. All of them could be things that are squared. And you either have a cosine squared and a sine squared, 2 different parts, or we have 2 cosines, or we have 2 sines. It's always the same setup. The sines are on the right, the cosines are on the left. Ones get swapped in, whatever you need to do to memorize that. And last, we have tan of 2 theta, which is going to be a fraction again. I'm going to squeeze it in there. 2 tan theta all over. It looks very similar to this, and that's because if you remember what I did to derive it, I kind of show you there. This fraction bar is not on the left side. I'm making it a little too big. I'm being a little extra. Let me go. I know. Okay, I'm sorry. 1 minus, I'm going to squeeze it, tan squared theta. Everywhere you just have a theta, those are just regular single angles. Everywhere you have a 2 theta, those are double angles. The next thing would be half angle, and that's really theta over 2. But right now, up to double angle, that is where we are. Again, we had 3 options for this. I'm going to put a little 1 in a circle, a little 2 for the second option, and a little 3 for my third option. So you did have 3 options for that one, only that one. And these are all of the identities that you should have memorized, or clearly written on a beautiful piece of paper in your notebook. Make a little card, make a little poster, hang it in your bedroom. I don't know. Okay. So make sure you have all of these written. And this is the beginning of this beautiful reference sheet for you. All right. I hope this little list is helpful. And if it is, thumbs up. If it's not, if you hate it, thumbs down. I don't care. I'm not.
Wait, Miss Hayes,
Yes.
scroll the paper down before you end the video because it's kind of cutting off.
Oh, it won't be cut off in the video as much as it is on
okay.
Google Meet, because on Google Meet, it has like all those things on the bottom, right?
Yeah.
Yeah. Come on, Google Meet. Let's get it together. I'm going to upload this guy to YouTube, but when you guys crop it off, you kind of mess with the, view. I'll go like that a bit and like that. How's that? So you can still see everything, and then we will center it a smidge. Is that all right? Better?
Yeah, that's good.
All right, good. All right. Thumbs up if you're happy. Thumbs down if you think it's stupid and you hate it. I don't know who does it. It's anonymous. Have a nice day. Bye-bye.